All right, so I have a friend who needs to enter a timesheet, and for whatever reason, it requires a Windows computer. It relies on specific versions of .NET Framework and some other extensions and things that are commonly built into a Windows PC. Now, he doesn't have a Windows computer, and he still needs to do this. So, the first option would be, and probably the easiest, best option is to go buy a cheap Windows computer and just do it, and you always have it, and you don't have to do anything extra crazy. However, my favorite option would be for me just to build him a Windows computer or virtual machine in a cloud provider and give him access to it from his phone. So he can remote desktop into this Windows computer that's in the cloud, do what he needs to do, and then he can turn it off. So it's only out there when he needs it. Anybody can do this. If you've got a Google account, you've got access to the Google Cloud Console, GCP. They even offer a free tier that lets you do things and not cost you anything at all for a specific amount of time and usage and things like that. I have far exceeded my free tier through the years, so I do have to pay. It's pretty cheap depending on what you're going to do. Sorry to step away for a minute. And you're only billed by usage. So what I'm going to do is I'm going to take some code using a language called Terraform. And Terraform is a language specifically for building infrastructure, servers, networking, firewall rules, load balancers, things like that. So all he needs is a Windows machine, and that machine needs access to the internet, and that's about it. So I use something called GitHub, which is for version control. You can go in, you can write your code, you can update it. It keeps the versions, things like that. So I have a public repository where I've already developed some code here to create some machines that will run in the cloud and do what I need to do. My code that I've already created will create two machines, so I need to change that to create only one. I need to add a rule so it can get out to the internet, and it needs to be as small as possible as far as like resources, CPU, RAM, storage, essentially. So super low resource Windows machine. It's going to end up being a Windows server because I've never deployed like an actual like Windows 11 computer in Google Cloud before. It's always a server operating system, but it doesn't matter. Server 2022 or 2000, whatever the latest version is, 2025. All it is Windows 11 that has a lot of the desktop features stripped out of it. Under the hood, it's the same code for the most part. So we're going to look at the Windows VM main.tf file. This is the main file that's used to build the computer or the virtual machine. In Google, they're called compute instances or VM instances. Okay, I'm not asking you to help. So what's going to do is it's going to create a Google Compute instance. It's going to name it this. This is going to be the machine type and the zone. These are in the form of variables, and the variables are defined in a different file. So it's going to point to the machine instance type and the zone over in this other variable file. Metadata, I can make the machine, when it first starts up, run some other code if I want to install applications. Any specific features that I need installed, I can make it do that inside of this script file or this Terraform file. Here's the network interface. This would be the NIC. You can think of it as a physical machine. The back of your computer has a network card. Okay, so this, even though it's virtual and it's just running out there in the cloud, it still has the same features. It's going to have a network card. This is going to be the network that it's on. This is going to be the subnetwork. Okay. This would be the second instance that I want to build. I don't need this. So we're going to take this resource out once we clone the code over there. So those are the mains. We'll look at the variables. This just defines your variables. So the GCP region, it's going to accept a string, and a string is just letters and numbers. Same for these. So all three of these variables are defined. Here is your actual TF-vars file. This is where your variables are stored. Your GCP project, that's going to be the project inside of Google Cloud that these machines are going to live in. This is going to be the region. Google Cloud is divided up into regions and zones. So this would exist on the east side of the United States. It would live in a data center that's on the eastern side of the United States. The zone would be East 1B. And we're going to define a network. So this is going to be the network range, 10.10.15.0/24. Another way to read that would be 10.10.15.0 with a subnet mask of 255.255.255.0, but /24 is easier. A Windows VM type, this means into standard, standard 2. This is the different levels of resources that the machine would have. So like 4 gigs of RAM, dual core processor. So you might have into standard 4, that may be 4 gigs of RAM, 4 core processor, and so on. So this is probably overkill for what I need, but it's okay. This is some more information that you can enter. You can give it an app name, a domain, an environment. This doesn't actually affect the machine. Your provider's file for Terraform is required. It basically tells what kind of different resources and plugins you're going to use. So the first one is we're obviously going to build this on Google. So we need to tell Terraform to use the Google provider. This is a different one. This is something that was related to what I do. We're going to take that out. This would be if I wanted an IP address on the internet to point to a name. So www.google.com points to an IP address of something like 64 dot to whatever. So with this provider, this would let me tie the public IP address to a name, and I'm not going to fool with that. Here's the GCP provider. Provider's Google, the version. And this would also be the provider information for Ultra DNS. So this is the network main file. This is declaring and building your virtual private cloud, which is just it's a network, and we're creating a public subnet so that we can get to it from the internet, or say I can remote desktop to it from my house. Here's our firewall rules. We'll modify this to meet our needs, but essentially everything is denied by default. So these machines do not have any inbound connectivity to them. You can't touch them at all unless you specifically open the firewall to allow it. So I know that remote desktop uses TCP 3389. So I have to allow TCP 3389 inbound to this machine, or he's not going to be able to open it up on his phone. The rest of this would be unnecessary. Port 80, that is web. That would be if it was serving a web page, or 443, mostly 443 these days. ICMP, not a great idea to turn on for denial of service reasons. So people could ping it. They can determine that it's online so they could attack it. I turn it on so I can ping it and make sure it's on from my workstation. Like, it's not that big a deal for me personally, and this would just be the instance type. Okay, so let's jump over to Google Cloud. So we'll do console.google.com, I believe. No, that's wrong. Google Cloud. Google Cloud. And we'll go to the console. And we're going to look at VM instances. We're going to go to Compute Engine, VM instances. So this is just going to be a VM instance is just a computer running virtually. So you can absolutely go through this interface and click and create whatever you want to. However, if you develop it in code, you're only going to have to write it one time and you can reproduce it from now on. No more clicky clicky. So if it takes more time to do it one time in code, it's worth it. So I'm going to leave this open here. We're going to open the Cloud Shell, which is essentially a Linux shell that lets me work inside of this cloud environment. Okay. Then we're going to do an ls. So it remembers I was in here before, so we're going to create a directory so that I can pull my code into. So I'm going to do mkdir Jordan. And we're going to cd to it. So we're going to switch to that directory. It's an empty directory. So now we're going to do git clone, and we're going to copy this code over into this environment. So I need to get this URL, and I'm going to paste it in here. And we're going to do git clone, bam. So now if I list that directory, you can see Terraform windows in there. So let's open the editor and we'll look in it. All right, this is the same code I showed you over in GitHub. We just pulled a copy over into Google Cloud. So let's go to our providers, providers block, providers main, HashiCorp Google. Oh, wait a minute, I am in the wrong directory. I need to be in Jordan because we're going to redo this. So providers main, we do not need this provider. Lines 8 down. So from open curly bracket to close curly bracket. And delete that. I don't need this provider information, so it can go. This looks okay. This looks okay. Firewall rules. I don't need web, so we're going to take this out. Allow RDP, that's remote desktop. So that's what he's going to use to get to the machine from his phone. And we're applying it to this network. Now, since that network doesn't actually exist yet, we can't reference it by like IP addresses. We have to reference it as a name because it will be created later once we run the code. So right here's our source ranges, 0.0. That all just means basically anything from the public internet. And target tag RDP, that essentially means that firewall rule is applied to the VM that has a tag RDP. Same way with ping. So this looks fine. TF vars. I don't think we need any of this. We'll leave that for now. I don't need ultra DNS config, so I'm deleting that completely. Variables is fine, Windows versions is fine, VM main, so we only need one VM. So let's go script, pull out all of this VM2 stuff. So should be open bracket, pull all that out. Let's take all of this stuff that's commented out. Well, it's okay. We'll leave it there. It's not doing anything. There's the tags. It's applied, RDP, HTTP, ICMP. We don't need HTTP anymore. And we're going to call this Aaron VM. Host name is going to be Aaron VM. Boot disk, it's going to create just a C drive like on any other computer, and it's going to be running the Windows Server 2022 OS. Looks fine. It's fine. It's fine. No issues there. No issues there. Okay, so we're good. We need to make sure all this is safe. So I'm going to do a Control-S. So our code looks good at this point. So we're going to jump back over to the terminal. And we're inside of that. We look here. We're inside of Jordan folder that I created and cloned all that. So with Terraform, you have to initialize that directory so it knows that we're going to use this directory to build our stuff with. So we're going to do Terraform init. Oh, empty directory. Sorry, got to go down to the next one. CD Terraform. We're going to do Terraform init. It's going to load the providers, deprecated. That's fine. Provider, okay, that block, they don't need to use it anymore. They're just telling us that, but it's still going to work. So at this point in time, Terraform is initialized, and we're going to run a Terraform plan. Warnings for undeclared variables, app domain, company. Okay, that's fine. Let's go back and clean that up right quick. It doesn't like this. Blah, blah, blah. So it doesn't like this stuff, which is fine. I don't need it. And we're going to save it and go back to terminal. I'm going to do Terraform plan again. This looks better. So essentially we're going to go right here after we run the thing, and it's going to come down and it's going to say Terraform is going to do the following stuff. Okay. It's going to create a firewall rule. It's going to tell you what it's applied to, what network, what source ranges. It is going to create the ingress and egress rule. That's inbound, outbound. It's going to create my computer, my VM instance. Okay. It's telling you all the information of what it's going to do, where it's going to be located. You'll see these like known after apply. So it doesn't really know yet until it's built. That's kind of how you can reuse this code in other places. I think the word is idempotent, something like that. Here's my VPC, my virtual private cloud. Here's my subnetwork. And the plan is 5 to add, 0 to change, 0 to destroy. Now we're going to do Terraform apply. And what's going to happen is you're going to see yes. You've got to authorize the shell to do this. And you're going to see at the bottom here, Google Compute Networking.vpc creating. It's going to step through all of those resources that I've asked it to create, and it's going to create all that for me. When I'm done, I'm going to have a working Windows Server 2022 virtual machine that you can access from your phone. And since it's in code, when I don't want it anymore, I can run Terraform destroy, and it will completely undo everything that it did. So here we go. It's still running. And we're done. So we got 5 resources added. Nothing was changed. Nothing was destroyed. We're going to hop back over to the console and look at the compute engine VM instances. You're going to see now that we have one VM, a computer. It's just a virtual machine. It's a virtual computer. They're different names, but you can think of it as a virtual physical Windows computer. It's a laptop that exists only in software. So it's on, it's running, it's given me a public IP address. So this is a internal would be for an internal network. You can't get to it from the internet. But it did produce an external IP address. So that means that I can take that IP. I should be able to connect to it from my laptop or from a phone or from anywhere that has internet access. So let's just start off by doing some basic stuff with it. Let's copy that IP and let's open a terminal on my laptop. And let's just ping it. Ping. We'll see if our rule set is allowing. It may not be up yet, but we'll see. Takes a little bit of time. Okay, let's try test net connection. Computer name. And the port is 3389. Okay, it's just not fully booted up yet. So once that machine fully boots, then we would be able to connect to it. So let's give it a few minutes. And let's go ahead and see if we can set a username and password on this guy. Set Windows password, username Aaron, set. And this is going to be the password for now until I change it. So we're just going to put that over here. Close. Let's jump back to terminal and see if it's allowing me to do anything to it yet. Okay, so now we see pings. A ping is essentially saying, hey, are you there? And if it is, it replies back. Now, if we check our other one, see if it's listening on that specific port, we should get a true. TCP test succeeded, true. So that means at this point I should be able to connect to this remotely. And let's try that right now. So let's go back over here so we can copy this IP again. Oh, click the wrong one. Go back. Copy. And we're going to pull all this down. We're going to open remote desktop. We're going to paste that in there. Control V to paste. Control C to copy. I hit enter. And more choices. Use a different account. Username's Aaron. Password is this. Okay. Yes. And now we should be able to connect to this new Windows machine that's running in the cloud. And there we are. So there's our Windows computer. And he would be able to install any software that's required to do timesheets, do anything he needs to do with it. And when he's done with it, he can go power it off, shut down. At that point, no charges are being incurred because it's powered off. And that is all there is to it. And we can literally smoke everything that we just did and take it all back, erase everything that was built by simply running Terraform destroy. And it will delete everything that it created. Anyways, this is my kind of fun. I figured I would share it. Someone might become interested in it just from seeing it. It lets you be a little bit creative, and it's not so much just memorizing and clicking around and knowing where things are. You kind of have to be creative. So it's a lot more fun doing this and being able to keep learning as you go through this. So anyways, I hope you thought that was cool. It's cool making a video anyways. It's like the first actual instructional video that I've ever made. So thank you and have a good day.